My last example here is about object detection with synthetic data. So we will build object detection model to recognize different types of seeds, and we will use synthetic data for this purpose. Let me show you how we will accomplish that. So this is the task description, but I already mentioned that. Okay, so for that we will also need just several apps. We will need training app, we will need serving app, and we will need some inference interface. And we will need app that helps us to generate synthetic data. So here is our problem definition. Those are images that we would like to be able to efficiently process and detect with rectangles all the seeds. And seeds might be of different types. Those are sunflower seeds, but we might have pumpkin peeled seeds, unpeeled seeds, and some mixture of seeds here. And unfortunately, we just have very limited training set. So we just have one relevant image, and this image is only partially labeled. We also have two irrelevant images, and those are partially labeled, and why I am showing you these images will be clear in a second. So we have production images, we have training data, which is extremely limited, and we also do have some backgrounds. Doesn't have to; those are unlabeled images. They doesn't have to be tables here. Nature will just do as well. So we have some setting here, and what we can do, we can run an app from a synthetic data category that will allow us to do the following. So we pick the foreground objects. This contains the three images, three partially labeled images, and we pick the backgrounds. Then we pick the classes, and you see here that the number of objects are actually quite limited that we have labeled. We pick data generation scenarios here and pick the target task that we would like to solve. And in this app we can actually press preview button, and it will generate what kind of synthetic data we might get. And once we are satisfied with what we see, we can just specify the number of target images, the number of target synthetic labeled images that we would like to generate, and click generate button. Once we do that, if we open these images in labeling interface, we will see this kind of results. And the images looks like this, so it's kind of a mess. But the point here is that we make the task specifically quite hard, so that it's hard for the model in the training time, in the hope that since it was hard in the training, it will be easier when we actually will start using model on real data. And the next step here is just to run a training app and pick the classes of interest, split the data, pick the model backbone, or some other parameters. We might play with advanced parameters here, and just click start training button after that, and this is a dynamic training dynamics that was produced by this app. So the next, and as a result, this app generates artifacts. So if you go to team files next and see what the app produced, go to weights folder here and just do the same operation, just copy the path to the checkpoint, and then run serving app and go to custom section here, paste checkpoint, and click run to deploy the model. So now our custom detection model is deployed, and then we run another app from inference category to take predictions from our custom trained model. So we connect to the model first, to the model that we have deployed. We pick the classes of interest. We specify some settings, some inference settings here. We can see the preview, and on the preview we can already see that the results are quite good here. And we specify the target project, the name for the target project, and click apply model to input data button. And after that, if we open the results in labeling interface, we will see something like that. So we will see that for each type of seeds, the results are actually very, very good. And that example nicely illustrates how we can use Supervisely to go actually all the way to go from the case when we have almost no data to the situation when we have not only label data but also we have quite a good model.